Hi, Will.
Hello.
I just sent you the last slide,
Okay.
1.2. I can't open it, it's still being scanned, so I just forward. Let me know if you can open it or not.
Okay. Yeah, it looks all right.
You can open it?
Yes.
Okay, great, then I don't have to wait for it to open. For some reason, my computer is very slow in scanning.
Good morning.
Good morning.
I have to say, Bob, I've been jealous of your Zoom background for some days now. It looks lovely.
Well, it's kind of like that here. We're not at the beach exactly, but we got lots of palm trees.
Morning.
Good morning, all.
Good morning.
Hi there.
Hey,
Good
Diana.
morning.
Diana, I just sent you slides.
Ah, yes, I receive it. I can open it, but I forward to Will and he can open it, so it's fine.
Thank you very much.
I was getting concerned.
Yeah, I was just away from the computer, that's all.
Good morning, Bob.
Good morning.
Your background view is beautiful. How did you make it? Huh?
Thank you. I wish it was real. We do have a lot of palm trees, but I'm not at the beach.
Huh?
I said, we do have a lot of palm trees, but I'm not at the beach.
Oh, you are from Florida?
Yes.
Oh, I see. But I thought first I thought, oh, you got a beautiful view. You are doing it on the beach.
Yeah. It's just an illusion. But it is sunny here today.
Yeah,
It'll warm up to almost 60 degrees.
good. Thank you.
Okay.
Nice talking to you.
Yes.
The time is now 12 p.m. I am Dr. Diana Wong, and as the designated federal officer, it is my pleasure to open the last day of the 4-day meeting for the RAC Augmented MARSSIM Review Panel. Yesterday's meeting went very well. A reminder to the peer reviewers, if you must step away from the meeting for a time, please send a note to me and also the chair. And send me another note when you're back. I'm going to do our check-in roll call and then start today's meeting. Dr. Brennausch?
Yes, I'm here.
Oh, thank you. Dr. Scott Emerson?
Present.
Thank you. Dr. Roland Banky?
Present.
Thank you. Dr. Harry Coolings?
I'm here.
Thank you. Dr. Lawrence Dahl?
Yes, I'm present.
Thank you. Dr. Tim DeWood is out today. Mr. Earl Fordham?
I'm here.
Thank you. Dr. Eric Golden?
I'm here.
Thank you. Ms. Barbara Hamrick?
Yes, I'm here.
Thank you. Dr. Kenneth Ian?
Good morning, present.
Thank you. Dr. Annie Kirstein? Dr. Annie Kirstein? Okay, we'll get back to her. Dr. Amy Cronenberg?
Present.
Thank you.
You're welcome.
Dr. Robert Lippman?
Hi, all.
Thank you. Mr. Dennis Quinn?
Present.
Thank you. Dr. Richard Smith?
Present.
Thank you. Dr. Daniel Stram?
Here.
Thank you. Mr. Sultan Sable?
Present. Good day, everyone.
Dr. Ward sick. Dr. Wang?
Present.
Thank you. Dr. Craig Yoder?
Present.
Thank you. I'll now turn the meeting over to Dr. Ausch.
Thank you, Dr. Wong. So first, I want to thank everyone for hanging in for the whole week. I know that that's a pretty big time commitment, and we really appreciate your efforts. So today, we have reached the last day, and the main thing on our agenda is the summary of each charge question. But first, I'd like to offer an opportunity to follow up on yesterday's discussions. I'm not aware of any topics that we need to revisit before we get into the summaries. Does anyone have anything? All right, then, looking ahead, we are going to go through each charge question in numerical order. And the idea here is that the lead discussants have prepared some summary slides that reflect not only the preliminary input that everyone provided, but then that has been updated, hopefully, with the contents of the discussion over this week. So I would encourage everyone to listen carefully and make sure that any input that you provided is accurately and adequately captured. That is certainly our intent. And that's the whole purpose of this review, to make sure that that happens. So please speak up if anything needs to be adjusted. Before we move into the first question, what I would like to do is go through the list of charge questions and who I have down as the lead discussant, just to make sure that I have everything correctly captured. I know that there were some substitutions, and I just want to make sure that I have it right. So question 1.1 will be Roland Banky, 1.2 Dan Stram, 1.3 Bob Littman, 1.4 Earl Fordham, 1.5 Craig Yoder. Then 2.1 will be Kenneth Inn, 2.2 Richard Smith, 2.3 Eric Golden, 3.1 Harry Cullings, 3.2 Larry Dower, 3.3 Barbara Hamrick, and 3.4 Dennis Quinn. Any corrections to that lineup? Okay, great. I've seen a lot of email traffic about the summary slides. For those of you who were just named, please make sure that you have arranged with Dr. Wong to have your slides projected on screen. So after we finish that summary, then the last thing for us on our agenda is for Dr. Wong to walk us through what the next steps will be. I know some of you have explicitly expressed some curiosity about that, but I know that we're all curious about that. So with that, let's move into the charge questions. Charge question 1.1, Roland Benke.
Thank you very much. This is Roland Benke presenting the response to charge question 1.1. Please advance the slide. This is the charge question. Are the revisions to MARSSIM concepts and methodologies technically appropriate, useful and clear, and do they provide a practical and implementable approach to performing environmental radiological surveys of surface, soil, and building surfaces? And then the specific part for charge question 1.1 is on this particular question. Please identify whether the inclusion and proposed implementation of scan-only surveys, section 5.3.6.1 and section 8.5 is appropriate, adequate and clear, especially a discussion on sampling for scan-only measurement method validation or verification. So please advance the slide. The associate discussants and myself appreciate the effort that was made in this area. We believe that perhaps this question leads off the discussion because there was acknowledgement of additional work to be done, and so it was put to the panel to have suggestions on moving forward. These suggestions are presented in 4 main considerations. The first is technical appropriateness of concepts and methodologies. The second, practicality of implementing approaches during surveys of surface soil and building surfaces. The third, on usefulness and clarity of MARSSIM revisions, including past misinterpretation of the term scan only. And fourth, verification of scan only surveys with sampling and laboratory analysis. Please advance the slide. On the first consideration for technical appropriateness of concepts and methodologies, here are the recommendations. Provide additional discussion on instrument response and calibration factors for the specific site or surface being measured. Discuss site-specific certified reference validation standards for scan-only calibrations with MQO targets. MQO stands for Measurement Quality Objective Targets. These are equivalent to a bullet on the last slide of this particular charge question. We will get there in due time. There's a reference to that in the particular presentation package. The third suggestion is to address overlapping fields of view for scan-only surveys with gamma ray detectors. Also justify subjecting the minimum detectable concentration for scan-only surveys, this is denoted as scan MDC, to 50% of the derived concentration guideline level for wide areas, also denoted with an acronym DCGL sub W. Moving on, provide a more complete description of scan-only technology advances since the last revision of MARSSIM. Develop a stronger, more formal connection between scan-only measurements and laboratory verification results to substantiate quantification requirements for scan-only surveys. Explain the relationship among these factors. There's a few of them now. The minimum detectable concentration recommendations for scan-only surveys, instrument calibration, including its rigor for the specific site under investigation, and statistical approaches, as well as the extent of conservatism in metrics selected for decision-making. Finally, there's a general suggestion to improve the consistency of minimum detectable concentration recommendations relative to guideline levels throughout the document and explain the rationale for differences. Please advance the slide. On the second consideration for practicality of implementing approaches during surveys of surface soil and building surfaces, we have the following suggestions. Present appropriate quality assurance and quality control definitions for the scanning technology and its recording output. Update the two-stage technique on scanning with frequent stationary measurements. Just as a side note, this particular technique was designed for older equipment without data logging. So there's a incentive now to update this for what would be our modern systems that have continuous data logging of detector location and response. Moving on, incorporate maps of radiation data generated by continuous data logging scanning systems. Also describe how scan-only equipment relates to data and measurement quality objectives, including measurement sensitivity requirements for scan-only surveys. Strengthen the description of relevant equipment for scan-only surveys, and provide additional detail on how to perform scan-only surveys. Illustrate scan-only implementation with validation from sampling and laboratory analysis, and present implementation examples of replicate measurements over defined scanning areas. Finally, add detailed insights from a case study. Please advance the slide. On the third consideration for usefulness and clarity of MARSSIM revisions, including past misinterpretation of the term scan only, we have the following suggestions. Revise the term scan only surveys to two particular types of terms or an equivalent type of terminology to distinguish generic scanning surveys from site-specific scanning surveys. So generic scanning surveys would be defined as follows: systems with no site-specific calibration that require validation from sampling and laboratory analysis. And then, contrary to those, there can be site-specific scanning surveys which indeed apply site-specific calibrations with reference validation materials that would not require additional confirmation from sampling and laboratory analysis. Moving on, clarify expectations associated with the recommended percentages of areas covered by scan-only surveys. There's an example here. Recommendation was for Class 1 areas to be scanned to 100% of the area. How might 90% of the scan area be addressed due to obstacles in the scanning process? Moving on, discuss the surface versus volumetric contamination in the context of scan-only surveys. Expand the description of scan-only survey impacts due to different particle emissions, and incorporate examples with readouts of representative scan-only technology. Also, elaborate on the extent to which scan-only surveys should be verified, and justify why final status surveys based on scan-only measurements would be inadequate. A general suggestion is also provided. It has two parts. Extend the cautionary notes on applying statistical tests to small data sets into other areas of the document. There was a useful cautionary note in the particular section reviewed for scan-only surveys. And illustrate the risks from small data sets with examples. Please advance now to the last of the considerations on verification of scan-only surveys with sampling and laboratory analysis. Maintain that collecting samples for laboratory analysis to validate scan-only measurements is a good quality control practice. And here's reference to that particular target from a slide earlier. It's recommend that the measurement quality objective, MQO, for laboratory analysis has a measurement uncertainty of at least a third of that for the scan-only measurements. In other words, the laboratory measurement uncertainties are at least 3 times smaller compared to the scan-only measurement uncertainties. Also acknowledge that site-specific instrument calibration with reference validation standards for the contaminants under investigation can remove requirements for subsequent confirmation by physical sampling and laboratory analysis. Also highlight that important distinctions between the scanning with stationary measurements versus scanning measurements with sampling for laboratory analysis. Please elaborate on those distinctions. Consider a protocol for data logging scanning systems with 4 subpoints. First, site-specific instrument calibration. Second, pre-selected locations for stationary measurements according to some sort of grid. And third, continuous scanning measurements at a constant speed. Finally, fourth, follow-up stationary measurements at locations suspected to have the highest concentrations. Also expand the verification discussion for scan-only surveys to include spatial concentration variability, contamination depth, and anticipated contaminant migration. And finally, a programmatic suggestion to consider scan-only performance testing programs to validate capabilities. I'd like to thank the associate discussants in preparing this material, Drs. Duvall, Golden, Hamrick, In, Cronenberg, Stram, and Wang. Thank you very much.
Thank you, Roland. That was a very comprehensive summary. Appreciate it. So panel members, is there anything in that summary that requires comment or adjusting? No? All right. Well done, Dr. Benke. Moving on, question 1.2, Dan Stram.
Hi. Okay. So next slide, I guess I don't need to read this one. Thank you. Oh, sorry about that. So there's 4 questions, requests asked in this charge. One is general, just comment on the inclusion and proposed implementation of scenario B. And then the next one is it appropriate to recommend that scenario B be used only in those situations when A is not feasible? And C, are methods for considering background variability and assessing whether the site is indistinguishable from background reasonable and technically accurate? And then finally, is the inclusion of proposed implementation of added requirements for retrospective power analysis and the use of the quantile test under scenario B technically appropriate and discussed adequately and clearly? Next slide. So overall comments, all the panel members support the inclusion of scenario B, at least in certain situations. The clarity needs to be improved, as well as access to key concepts and references. In some cases, concepts are used before they're defined or defined differently in different places. I think there's a recognition by everyone that the terminology is complicated. You have to get used to a lot of different terms and acronyms. They all need to be understood in order to do power and sample size calculations for either scenario A or B. The terminology is only standard throughout the multi-agency manuals. Well, and it probably has been adopted by other things too, but it's certainly not ubiquitous throughout statistics. It's hard to to Google any one of these. You come up with relatively few hits, and most of them just reference back to the MARSSIM and the MARS projects manuals. But once learned, the terminology makes sense, I think, to someone, at least with someone with appropriate statistical training, and all involved in the MARSSIM process need to know the terminology and concepts. So regulators, contractors, etc. And this applies not just to MARSSIM, but to the other multi-agency manuals. And so the question, one question I think that remains in my mind is whether someone without good statistical understanding can use this as a reasonably good cookbook. I mean, the only comment that I got on this was that everyone needs to be on the same page, and I certainly agree with that. Next slide, please. So talking about the first question, the second question, is it appropriate to recommend that scenario B be used only when scenario A is not feasible? So scenario A is when you assume that the site is contaminated above the DCGL and as the null hypothesis, and then you try to reject that in favor of being less than the DCGL. And scenario B is the opposite. If you would assume that the null hypothesis is that there's no contamination and that the data, you use the data to try to reject the null in favor of there being contamination above the DCGL. So the panel is split on this with two members requesting or that more leeway be given in applying scenario B when scenario A is still feasible. In other words, they want to broaden the scope of the cases where scenario B could be used. But with a cautionary note that retrospective power analysis needs to be done. The reasons for this were two were noted. One was that there's difficulty in proving to the regulator that scenario A is not feasible. And second, there's objections to the presumption that the burden of proof shifts from user to regulator when scenario B is utilized. The remainder of the panel accepts that it's reasonable to recommend that scenario A should be the default scenario, except when the DCGL is close to 0. Next slide. Our methods for considering background variability and assessing whether the site is indistinguishable from background reasonable and technically accurate. This is the most statistical of the statistical. I mean, all of these are statistical. Here, we agreed that the Kruskal-Wallis test was appropriate for the detection of background variability. And so we accepted that. And also that ANOVA gives appropriate estimates of the variance of the random effects. And that's true even in cases where there's non-normality. But they go on to use the results of the ANOVA using a very weak bound on the confidence limits. So it gives very wide confidence limits. And based on the wide confidence limits, they suggest LGBR, so lower bound of the gray region, of 3 times omega, omega being the square root of the variance for the between background variance, basically. And this 3 times omega was which corresponds to the upper 10% tail using the Chebyshev inequality. It seems just too large by me. Well, I shouldn't have said me. Seems too large by one panel member who suggested using half that, basically, which corresponds to the upper 10% for a normal distribution. Here, as I said before, omega is the standard deviation parameter from the ANOVA estimates. So it's the square root of the variance of the random effect for the background. The clarity of presentation could be improved. To give an example, example 9, which is the one that, well, I forget now for sure which one it was. It depends on equations and tables from, it's this one, New Reg 1505 and equations 13.3 and 13.13 and tables 13. It's all over the place, in other words. So MARSSIM, and then finally MARSSIM should acknowledge underlying assumptions of statistical tools and include more cautionary notes indicating under what conditions the statistical tests become unreliable. Okay, next slide. Is the inclusion and proposed implementation of added requirements for retrospective power analysis and the quantile test while using scenario B technically appropriate and discussed adequately and clearly? The panel was unanimous, I think, about the importance of retrospective power analysis in scenario B. If you can overestimate the power in the design phase, then when you get to the actual data, you can see that your estimate of sigma was too small, therefore you had overestimated the power, and you don't really, and not rejecting the null hypothesis is not strong evidence that you really have a site that meets the requirement or has, in some cases, no detectable residual variability, residual radioactivity. The panel found that the Wilcoxon test was technically appropriate, adequately discussed and clear. The drawback is that it tests for kind of the wrong metric, which motivates the use of a test for a shift in the tails in the quantile test. And I think that, well, again, the panel, I hope, agrees that a better description of the quantile test, literature references, and discussion of the underlying null and alternative hypothesis, and some power considerations should be needed in the MARSSIM revision. And, very importantly is to develop a sort of a front to end case study where all the statistical tools are applied and worked out in detail to support the decision-making process. I think this is the last slide. If not, please advance. Okay. I hope I captured the essence of our discussions.
Thank you, Dan. So before I open it up to the entire panel, I'd like to perhaps touch on the issue where the opinion is split, the issue of when scenario B should be applied and to what degree scenario A should be considered a default. As Richard Smith, I think, mentioned earlier in the week, there is precedent for this kind of a situation from the larger SAB. We certainly want to make sure that any differences of opinion are not the result of, misunderstandings, people using terms in different ways or unclearly. I think we're past that. And what we have here is residual, simply diversity of opinion on a scientific matter. That being the case, I think it's important that the report capture that diversity of opinion. And, we'll just be straightforward about that, that maybe, I think, Richard, that you had said that, like the way the SAB did it was a majority of the panel held this opinion and a minority of the panel held this other opinion.
Yes, that's certainly a good way to put it. I would just like to seek some clarification of the point, is it actually the case that two people disagreed with it? I'm not even sure whether I'm being counted as one of the two. I mean, my feeling, I expressed reservations about it, but I think in the end I was willing to accept that scenario A, scenario B dichotomy is okay.
Yes. Thank you. Yes, there were two, and maybe they could they could. Is this the time to hash this out?
This
right
is
now,
Barbara.
or is-
This is Barbara, and I know I was one of the ones who commented remarked about the characterization of scenario B, and also the difficulty with the regulators. And it is not that I oppose recommending scenario A. be used unless it can't be used, and then you use scenario B. What I really objected to was in the text where it characterizes scenario B as not as valid as scenario A. And there's some negative language in there, and it's not a technical thing. It's just the way it's talked about, which does in fact influence the regulators. And that was more really my concern, is that, you know, you have this scenario that works unless you have these circumstances, in which case you use this other perfectly good scenario, and instead of characterizing it as something that, you know, we really don't want you to do this, but, you know, if you want to try and talk your regulator into it, you can try that. It was more the characterization language that I objected to.
I see. So does that mean if we change the, well, I don't know how it necessarily is to change the slides, but just the general write-up, which we'll hear more about from Diane.
Yeah, I don't think it's necessary to change the slides. Oh, and I'm not sure I'm exactly making the point.
Oh, no, you.
And maybe I need to write it up, but.
I mean, so can I count you then as basically in favor or accepting that it's reasonable to recommend scenario B only when scenario A is infeasible, that is a reasonable
Yes.
recommendation?
Yes.
But you'd like to have it, any text about, or just strengthen the text about the validity of the test when retrospective power analysis shows that you had good power to reject the null hypothesis under
Yes.
the alternative that you had supplied.
Yes, I'm in agreement with that.
So,
Okay.
so maybe we can all agree with the following sentence, that we are satisfied that we are satisfied that scenario B can be used provided a suitable power, and provided it's accompanied by a suitable power analysis. Would that be, no, provided it's accompanied by an appropriate power analysis. Would that be something that everybody could agree to?
I can agree with that.
This is Wei Xiang Wen, and I believe I'm the other person who has some opinion about there's too much subjectiveness regarding whether the scenario A is feasible or not. And I agree with Barbara's statement, and I'm not opposing, you know, the presentation, you know, Dr. Shen presented. I just think more clarification will be very helpful.
So again, you don't want to see it being sort of the little brother or the little sister of scenario A. You want it to be fully accepted and but used but used when it's appropriate, and when it's appropriate is when you've got very low background.
Mm-hmm.
Yes.
Yes.
Okay. All right, I think we can live with that. I asked the chair, does that seem to resolve the question?
It certainly does to me. It sounds like you all have hashed this out and come to a better understanding where the consensus can be reached. So, given that, are there any other comments or corrections or input on charge question 1.2?
Could I make a quick interjection on a different point? This is a much smaller point, but Dan, you did email me about this 3 omega recommendation.
Yeah.
I did respond to you, but it was very late last night, so maybe.
I'm sorry, I've been away from my computer.
Yeah, no problem at all. So, I mean, the point is 3 omega came from a Chebyshev inequality, which I agree that's a very, very weak way of doing it. It's basically, you know, going out what's the maximum possible amount.
Right.
you suggested it should be 3/2 omega on the grounds that will correspond to the upper 10% point of a normal distribution. Well, in fact, the upper 10% point would actually be 1.64 omega, not 1.5 omega. And I suggested as a compromise 2 omega. And let me just explain my reasoning for that. 2 omega would correspond to a T distribution with 5 degrees of freedom. And you might say, well, why the heck would anybody assume that? Well, here's my logic, that we want to allow for something that's significantly longer tailed than normal, but not so long tailed that you're really looking at extreme distributions which would never arise in practice. So I thought the T5 distribution might be a reasonable compromise between, on the one hand, you have normal, but on the other hand, you assume nothing. That's what Chebyshev does. And maybe, changing 3 omega to 2 omega is a reasonable compromise.
I think that's probably fine. 3 omega is very large. 2 omega corresponds roughly to it's the upper tail is what? That's 5%, right?
Yeah. I mean, just in everyday statistics, if you go plus or minus 3 sigma, you're being very, very conservative. It corresponds to something like a 99.5% confidence interval. And most people would say that's a higher level of confidence than you need, in normal theory calculations. That's a higher level of confidence than you need for practical use. And I think what you're trying to get at here is not something that's that strong a confidence bound.
I think I'd be willing to go to 2. I don't know if the other committee members have an opinion. 2 times omega. This whole discussion comes out of just one very small part of the manual, but it was raised. It's all in example 9, I believe.
I see that Ken In has his hand raised.
Sure.
Good morning. It's a slight deviation from the deviation. We're talking about, whether it's 3 or 2 or 1.5 omegas. I'm one of these kinds of guys that says, well, show me. And while we can talk a lot about the statistical ways of dealing with this, I was wondering, does it make any sense to look at the data, plot out the data, look at the distribution, and see whether or not we're good enough to verify all these omega assumptions?
Well, that's what I would do if I was talking to another statistician. But I mean, what we're trying to do here is to come up with a rule of thumb that people can apply without doing that. So, if that's what the panel wants to recommend, I'd support that. But that wasn't what I was hearing as the overall flavor of the panel discussions.
Well, I guess my point is, you don't have to be thinking in terms of statistician theory. You look at the real data, and you make your decisions from it.
If you're confident that the users of these procedures know how to do that correctly, then I'd support you.
Perfect.
I think we can put in some language that would cover that, although it.
But I mean, obviously, I'm expressing doubts whether that's actually true. That's my problem. That's
Well,
why.
let me ask a clarifying question, because I'm not as intimately familiar with all these statistical tests as you all are. Are you suggesting that the EP or the MARSSIM working group do the kinds of analysis that you're talking about, or rather, are you suggesting that language be added to the manual that directs the users of the manual to do that kind of an analysis.
Who is that question that aimed at?
I guess I'm going to aim it at Dr. Stram, but really all of you, the three of you, Ken, you and Richard, what exactly is the recommendation that you're talking about?
Well, I mean, I guess you can look at the data and see if it's normally, distributed. The estimation of the variance components is legitimate if you're not, normally distributed. But the behavior of the test will become more extreme if the data is not normally distributed, and in particular if it has a long tail. Then I think you'd see some real differences where maybe not quite as extreme as the Chebyshev inequality, but the using a normal is just not appropriate. So I think we could put in some cautionary text, or ask for some additional cautionary text. Maybe I can add that to the, I think it was the already existing point about needing to check statistical assumptions. And
just one suggestion here. I mean, maybe put in a little bit of text along the lines of, say, you'd use 2 omega unless it looks as though the data contain very large outliers or something like that. That would sort of encompass Ken's point, but without forcing the user to go through a whole bunch of different statistical tests, which I'm really trying to steer you away from, because I don't think it's a good idea to expect users in the field to do that.
Yeah, that to me sounds like a good resolution.
Well, I see that Cynthia Barr from the NRC has her hand raised. Cynthia, do you want to weigh in on this?
Yeah, I just wanted to say that I agree with all of you guys. And the example is written up so that you would set it based on the DQO process and that you'd work with your regulator. The example was provided just so you would have, a default value or something to look at, but we could certainly add in the case of the normal distribution and 2 sigma, just as another value. So I think that kind of handles Dr. Smith's rationale that you really want to help the user out. But at the same time, you want to make sure that what you selected was valid. So I guess I agree with everybody's opinion, but I just wanted to point that out. It's not set in stone to be 3. The example actually looks at the range of values and finds that it was within a factor of 3 standard deviations for that particular example. So, I mean, you still have to justify the value as part of the DQO process, but there's some suggestions on values that could be used. Is that okay?
Okay, yeah. So we'll suggest that the value of 2 also be considered.
Right, we can add that in too.
If it's not too if the data is not too unnormally distributed, sorry, long-tailed.
All right, thank you. Anyone else on the panel want to weigh in on this particular matter or anything else related to charge question 1.2?
This is Zoltan Sabo. My take with these type of manuals is at some level they do have to provide some kind of specific guidance. And that's why, like in this previous discussion, I kind of agree with Dr. Smith that you probably have to have some value as a baseline, and his rationale for using the 2 omega was perfectly fine. And then, maybe put in the caveat that if you can demonstrate or want to do the statistics and demonstrate that it should be something else, that's fine. But I think at some level, at least some indication of baselines need to be in there. And as pointed out by the NRC person, sorry, I missed who it was, but right, the problem says 3, but it may be that 2 might be a better number. Anyway, I guess my take on it is the manuals do have to have, with the use of the word manual, you do need to have some clarifying, guidelines of this is what's reasonable or optimal.
All right, thank you. Anyone else?
I guess I'd follow that up with another comment on the previous discussion regarding the language with scenario B. I guess my understanding at the end of the discussion was that scenario B is going to be accepted to a full acceptable scenario as opposed to the little brother. That is, little brother being only acceptable if scenario A doesn't work. Did I understand that correctly? I just wanted to make
No, it's a little more involved in that. We're accepting that it's reasonable to only allow scenario B when scenario A is infeasible. We're accepting that, but we just
Right,
are asking
okay.
for change in the language that makes it sound like we're very reluctantly accepting it or something like that.
Right. Okay. That's, yeah, sorry. I just wanted to make
No,
sure.
that's fine. It's pretty complex.
Right. No, great. No, that's the
Well,
way I thought I understood it too.
The language I'm really looking for, yeah, I am not disagreeing with saying it should be recommended only in cases where scenario A will not work, but that it is a perfectly valid way in those circumstances. This is a perfectly valid way. You don't have to say perfectly, but to somehow characterize it as
As long as the retrospective power is controlled.
Right.
Yeah.
That it is technologically and scientifically acceptable to do this. Because the way it sounds right now is like, well, you really don't want to do this. And that what that does, and this is not a scientific or technical thing, but that trips up the regulator, and it makes it very difficult then to demonstrate, even when you have the circumstances that meet that, to say, yes, this is just as valid.
Right. So we can say that I'll try to strengthen the language.
I'll
get to the report. We'll all have a comment, chance to comment on the written text.
Yep.
All right, Ken, I see your hand raised again. Is that?
Yeah, I was, before getting to scenario B, I'd like to be sure that the instrumentation and the effort that's used to do the measurements have, there's a serious effort to control the uncertainties of the measurements, so that you've actually found yourself in a place where, well, our instruments cannot, and you've made a serious effort to do this, our instruments cannot distinguish from 0. And because I can imagine someone trying, doing the work and saying, well, we've exhausted all the instrumentation that we currently have in our resources, without really trying to stretch and make a really good effort to get down to that level. Am I making any sense?
Yeah, you are. You're talking about the situation where the DCGL is close to 0. It wouldn't apply if it was the DCGL was actually 0. In other words, you're looking at the trying to have there be no residual contamination left.
Yeah, I thought scenario B was the card you pulled out, and it's the legitimate card that you pull out when you can't tell from zero. And so when I look at the list of equipment in, what's that, Appendix H or something, they've listed stuff like accelerator mass spectrometry. Well, wow, not everybody has that in their laboratory. But I'm not sure that I'd like to say that, well, we've done the best with our scanning surveys, and where we can't tell from zero using scanning surveys. Well, okay, so you go the next step and you take samples to the lab. Well, even there in the laboratory, there's a variety of techniques to use, and let's not take shortcuts before we have to pull out that scenario B card.
Okay, we'll strengthen that.
But I would agree that once you reach that point, that scenario B card is the legitimate card to bring out. And I would think that this discussion is done between the regulator and the person bringing the data in. And I presume they're connected at the hip somehow, and in terms of trying to make the best decision going forward. Thank you.
Yes, thanks for your comments. I think trying to say, that this is depends on the methodology, depends on the measurement methodology, the level of detectability away from zero, and that substitute scenario B should not be used when there is adequate and reasonably achievable appropriate way of refining the measurements themselves.
Thank you very much.
All right, thank you, Ken. Anyone else for any input on charge question 1.2? All right, well, thank you, everyone. I'm glad we were able to work through that thorny issue and come to some resolution on it. I appreciate your efforts on that. The next charge question is 1.3, Bob Littman.
Thank you, Brant. First, I'd like to thank the sub-team members here for their contributions. Cullings, Inns, Smith, Stram, Szabo, Wang, and Yoder. We had a very far-reaching question, and there was a lot of input from everybody, and I certainly appreciate it. Charge question 1.3 had 4 different parts, and the presentation here addresses each of those 4 parts separately. So the first part is the proposed implementation of all of the concept of measurement quality objectives adequately and correctly described, including the concept of measurement uncertainty in Chapter 4 and Appendix D. And I might add that this also overlaps into Chapter 6 a little bit, which we'll talk about in a few minutes. The second part is the proposed calculation of measurement uncertainty consistent with the concept of measurement quality objectives. The third is the method appropriate and practical for both laboratory and field, including scan measurements. And then the fourth item was, please comment on the concerns of stakeholders that calculating measurement uncertainty for field measurements makes the survey process difficult to implement. In addition, please comment on whether recommendations provided by NIST, ANSI, IEEE, and MARLAP for measurement quantifiability should be incorporated further into MARSSIM Rev 2, or whether the current recommendations should be left as is. That is the original MARSSIM requirement that MDC, MDA should be set at 10 to 50% of the action level. So, like I said, we'll address each of these separately. Next slide, please. So for A, was it adequately and correctly described in Chapter 4 and Appendix D? The material in chapters 4 and 6 in Appendix D seem to be consistent with relating measurement uncertainty to MQOs in the general sense. However, there does not appear to be a rationale that relates the way to determine if instrument uncertainty meets the measurement quality objectives. The basis for selecting instrumentation and methods to adequately classify sites, etc., relies on proper instrument selection before measurements are performed. And I think that this in particular is very important because this connects not only the measurement quality objectives to the actual measurements, but it also relates back to the data quality objectives in the planning process. MQOs should use exact terminology. For example, standard uncertainty, combined uncertainty, or expanded uncertainty, and the coverage factor, K. Appendix D lists measurements for inclusion in uncertainty determination. Need to identify the type A and type B uncertainty components, expected values, sensitivity coefficients, and covariance effects. And then specific examples of how to calculate a combined standard uncertainty for measurements is needed. And again, these issues of the type A and type B measurements and what was also referred to as shared and unshared uncertainties, these need some further clarification in the document. I think it would be very helpful to include the concept of type A and type B and also subdivide that into shared and unshared. And I believe Craig had described including these two different descriptions of the uncertainty components as putting a three-dimensional tilt on the uncertainty problem, which I thought was actually a very good explanation. Next slide, please. So we're continuing with the adequately and correctly described in Chapter 4 in Appendix D. Recommendations regarding how to set the MDC based on the upper bound of the gray region are generic and not based on method or measurement uncertainty. And this is somewhat of a, I don't want to call it a troubling concern, but the MDC seems to float and is not really related to the gray region, either the upper or the lower bound. Relationships between MDC, MQC, and the upper bound of the gray region are not well defined. The MQC is mentioned in Chapter 6.4. How to calculate it should be included in that chapter or in Chapter 4, or potentially using a reference like MARSSIM where it describes the MQC as well. And then overall, Chapter 4 and Appendix D relate measurement uncertainty and MQOs, but are short of details on how to relate the MQOs and measurement uncertainty. Additional details to the examples are needed and integrated into case studies. And the last four words here, integrated into case studies, I think that's a common theme for answers to many of the charge questions. Next slide, please. Part B wanted to know if the proposed calculation of measurement uncertainty was consistent with the concept of measurement quality objectives. Our conclusion by all of us was that the measurement uncertainty and how it should be determined is not adequately described. The description of its determination is scattered in the manual and in the appendix. The references to uncertainty in MARSSIM, more than 300, are valuable, but the information overload on the user is extraordinary. A specific reference to a specific mention in the manual text itself is going to be very helpful. But having so many different references may be distracting. I would think they'd want to consider keeping in those primary references that they've got with his actual references in the text. An adequate example of realistic determination of final measurement uncertainty, the CSU, is not provided, but should be integrated into the case studies. And method uncertainty is not addressed in the selection of instrumentation. Other concepts in the MARSSIM rely on all of this. The MDC and the MDA concepts require that measurement and method uncertainty be a well-established measurement quality objective. scanning, and in-place measurement selection require a well-established requirement for measurement uncertainty. And then finally, whether or not a DCGL EMC or DCGL W has been exceeded is based on those uncertainties. Next slide, please. Part C wanted to know, is the method appropriate and practical for both laboratory and field, including scan measurements? Laboratory instrument relationship of MQOs to the required method uncertainty is described in MARLAP. And that required method uncertainty is an a priori determination based on data quality objectives. The MARSSIM method for relating measurement uncertainty to MQOs is inconsistent with the guidance provided in MARLAP. And again, I know I harp on this a little bit, but these documents can work very, very well together if they use the same terminology and the same language. For the experienced measurement quality objective and measurement uncertainty practitioner, MARSSIM is a resource for planning and execution of site cleanups. However, the novice is faced with understanding the right questions to ask. From a practical standpoint, the manual is lacking details and sufficient examples. For scan measurements, operator speed of scan, distance from the surface, and experience all contribute to shared uncertainty. This contribution to the measurement uncertainty is not discussed and is not part of the MQO discussion, and in general may contribute a greater part to the combined standard uncertainty than just the counting uncertainty. And again, these concepts of shared and unshared uncertainty fit also in both type A and type B uncertainties. From the practical approach for a manual user, an example showing an evaluation in interpreting the results and reaching a final decision accounting for possible differences in outcome depending upon approaches to data quality management would be useful. Missing throughout Chapter 4 are appropriate call-ins to details that are present in Appendix D that would strongly help in using Chapter 4. Next slide. Part D was calculating measurement uncertainty for field measurements correct? There is no mention of the MDA, MDC set at 10% to 50% of the upper bound of the gray region in the text of MARSSIM. The proposed range cited in the charge question, even if it was in the text, is arbitrary and not based on the project-specific data quality objectives, which must include method uncertainty for the instruments selected and other contributors to the measurement uncertainty. The instrument selection process must ensure that the method uncertainty includes not only the instruments, but the process of the measurement meets the project DQOs. Calculation of an MDC or an MDA is an a priori process. These concepts are not addressed in the NIST, ANSI, IEEE documents, and is unclear what from those documents should be used in MARSSIM based on the text in MARSSIM. The guidance provided in MARLAP could be considered for inclusion in this manual, apart from the material about MQC. MARSSIM does not cover in sufficient detail Type A and Type B uncertainties, especially as it applies to scan measurements. The Type A and Type B uncertainties defined in the NIST and the ISO documents, Type A determined using statistical processes, Type B determined based on professional or other knowledge. Both types of uncertainty can contain either shared or unshared measurement uncertainties, which adds a third dimension to the uncertainty equation. A table or description collecting the most common of all these uncertainties with a realistic example will be a significant help to those performing measurements. If the uncertainty process is too difficult to implement in some limited circumstances, a summary table of various approaches or considerations that might be employed instead to limit effects for data analysis and decision-making may be a useful addition. Including scan-only surveys increases the sampling design error, and thus measurement uncertainty becomes more critical. Next slide. So the next several slides, the first two are recommendations and the last two are mainly editorial issues. Under recommendations, we said that the MARSSIM should include detailed step-by-step worked out examples of setting up sigma and U sub MR uncertainty component lists for a few cleanup scenarios with the expected measurement systems to be used. And again, this concept of the step-by-step examples worked out in detail is very important. In some of the examples throughout the MARSSIM, there are steps that are skipped over that are sometimes difficult to find out how you get from part 1 to part 2 in the steps. A discussion should be included describing how to select field scanning or in-place measurement instruments. The use of standard terminology and symbols for uncertainty, standard deviation, and all statistical parameters should be used throughout the manual. Examples of determining measurement uncertainty for field scanning instruments should be included with details of how the calculations are performed. Included in these examples should be consideration for the following: reliability, robustness, dynamic range, sensitivity, specificity, calibration, sample collection, heterogeneity, attenuation, temporal effects, operator skill, speed, distance, blank result, surface shielding, and self-shielding. A table or description collecting the most common of these uncertainties should go into Chapter 4. If the uncertainty process is too difficult to implement in some limited circumstances, a summary table of various approaches or considerations that might be employed to limit effects for data analysis and decision-making may be a useful addition. Next slide, please. Explicitly define the terms repeatability and reproducibility as they are used in the document. A discussion of where in the gray region the MDC or MDA should lie is needed. A discussion of detectability versus measurement result based on the measurement uncertainty is needed. Include a discussion of type A and type B uncertainties and how shared and unshared contributions to the measurement uncertainty fit into the type A or type B definitions. Formula 618 should have a better statement of context. It is an approximation appropriate when the function being evaluated is approximately linear over the region of uncertainty. It does not assume the different error terms are uncorrelated, and if that's not true, there needs to be additional terms reflecting the correlations. In section 6.4.4, there should be at least some discussion of when this kind of normal theory confidence interval is appropriate, and some mention of the t distribution when the standard deviation is estimated from data. Next slide, please. Editorial changes. The U symbol should be included in the symbols nomenclature and notations list. The U and sigma symbols should be used where appropriate, particularly where delta over U should be used. Appendix D, D53, page D53, line 1 to 3. The uncertainty of a measurement expressed as combined standard uncertainty concludes the counting uncertainty of the measurement instrumentation and the sum of the errors associated with the measurement system. It's recommended to reword the sentence by using the equation 618 terminology that the uncertainties are combined as the root sum of squares. In Chapter 6, page 631, example 8, illustrates some of the steps used to estimate an uncertainty, in this case, sigma sub y, for a measurement counting process. Recommend detailing all the steps of this process for estimating measurement uncertainties and also for the theoretical total standard deviation of the population distribution being sampled, sigma, that is used for MQO delta over sigma. Terminology used throughout MARSSIM should use the guidance of NIST 1297 and ISO GUM, the Guide to the Uncertainty of Measurements. The following abbreviations appear nowhere in the text and only in symbols, nomenclature, and notations: Y sub C and Y sub D. In figure 4.1, the wording inside the information boxes reference sections of Chapter 4, for example, 4.3, 4.4, etc. These do not reflect the title of those sections of Chapter 4 and do not reflect the content of those sections. On page 44, line 21, samples are authentic. This seems to be an odd choice of words here, and perhaps using words like reliable, dependable, or trustworthy are more in keeping with terminology. On page 4-5, lines 6 through 8, why not have some of these reference tables located in Appendix D or even in Chapter 4? This part of the discussion is central to the entire chapter. Page 4-5, line 16, measurement performance criteria are not defined here. The term is mentioned in Appendix D, point 2.2, but is not defined. There should be a definition someplace, either in the Chapter 4 or in the appendix. 428, scanning speed, operator training, calibration, and tracking of these calibrations needs more details. And finally, page 431, line 37, MARSSIM recommends that a realistic or conservative estimate of the MDC be used instead of an optimistic estimate. An example of what might be realistic or conservative would be helpful, like 95% of a type 1 error. And I believe that's the last, oh, we got more, one more, sorry. Page 455, line 18. Alpha of 0.05 and beta of 0.1, we should include type 1 error and type 2 error before alpha and beta. And then Appendix D, page 23, line 8 to 11. More information on scenario B can be found in the NRC draft report, New Reg 1505. Why not discuss the implications of the type 1 error for alpha for scenario B? While the citations are thorough, the concept is critical at this point of the discussion. An expansion of a brief summary is reasonable. And I think that's the last slide.
All right, thank you, Bob. We'll give you a chance to catch your breath. I see that Catherine Sneed has had her hand raised for a while. So Catherine?
Oh boy. Hey, Catherine.
Actually, I was hoping to go back, Will, if you can, to the very first, I think, of Dr. Littman's slides. It's the one in which he had the charge listed on it. Is it possible to pull up Dr. Littman's slides one more time and look at the slide with the charge on it? I was going to ask a question.
Oh, there we go. Next slide.
Yes, that one. So I first want to start out by acknowledging the giant amount of work that Dr. Littman and his crew have done in evaluating this. This is a very thorough evaluation, and I think it indicates quite a bit of work that the work group needs to consider, especially where it comes to measurement uncertainty and taking Dr. Yoder's very good points into account from yesterday, or I think it was yesterday or the day before, where we looked at how measurement uncertainty really combines into to affect that minimum detectable concentration calculation, and we need to be looking at that very carefully as well. So we definitely acknowledging some great points that the work that the group has made here, but I do want to ask one clarifying question.
Sure.
So when I look at the charge, when I put this charge together, A, B, C, and the first sentence of D, I had intended to be about measurement method uncertainty. Starting with in addition, and maybe it's unclear because of the way the charge was written, and that is entirely on my head here. That was meant to go into a separate MQO, which is to look very carefully at the use of the MQC and whether or not incorporating the MQC into MARSSIM, which is a concept that was not in MARSSIM Revision 1 at all, was needed, or if we could work with the existing and already in use concept of the MDC, looking at, and I think there was a reference in the discussion on this to a section of MARSSIM where there was a discussion on how the two could be looked at in relation to each other. And I think that that's a question that I'm not certain I've heard the answer to in a way that I could could walk forward with the recommendations of whether or not we could work with the MDC or whether or not we need to incorporate that MQC into MARSSIM moving forward. Maybe you could expand upon that a little bit.
Okay, from my perspective, Catherine, the MQC is at least in radiological analysis, my opinion is the MQC is not a parameter that has a lot of value. And when I saw that it was in there, I quite frankly didn't want to comment too much on it because it wasn't part of the charge question. But I don't think it belongs there. I think, like I've indicated earlier, the MDC, if we take that as an a priori measurement and then look at the actual detectability and whether or not the detectability is less than the MDC, those are the essential points of looking at the data and then determining that that data is valid and can be used for decision making. The MQC, on the other hand, is to me, it's a little bit artificial. Somebody chose, in that 1978 document that the EPA put out, somebody chose a factor of 10 above the standard deviation of the background standard deviation. That was just somebody said that's a good idea. And it really has, so the MQC is kind of an artificial barrier that really doesn't fit into the gray region concept and the concept of measurement uncertainty. I didn't realize that was a part of that last part of the question there. Otherwise, I think everybody would have kind of had other thoughts on it. And I welcome the other team members to jump in on this and, opine about their thoughts about the MQC.
Okay, let's see. I have raised hands from Ken first.
Why don't you get to me last? I might be able to go shorter.
Okay, that's fine. Zoltan.
I think we had a short discussion, again, I'm not going to remember which day, about this particular topic, though. It was kind of under the section of defining the MDCs. But I think at that general point, I think the discussion probably, Bob has already pretty much summarized it. MDC is the preferable approach here. MQC was rather arbitrary. That was the feeling. And the only way I think anyone was okay with it being included was for historical reasons, maybe in an appendix only as a possible initial estimating tool, but not as the final approach to MQO. Again, someone else disagree with me if that's doesn't fit the recollections, but that's the way I kind of recollect this discussion.
All right. Ken, back to you.
My recollection is when Lloyd got into this detection limit discussion back in 60s and 70s.
68.
68. I was right in both counts then. I think he had a diagram, and he says, well, at the critical level, these are the kinds of things you want to think about. At the decision level, you want to think about these other things, and these are near that you're just able to detect stuff. But if you want to really quantify stuff, then you want to have a quality of, some kind of quality to your measurement, and maybe a 10% uncertainty is worthwhile. And so a 10% uncertainty, you might be working about 10 sigmas above your background. But when you're talking about your MDC level, you're 3 or 4 sigmas above background. And when you're at the critical level, you're about 2 sigmas above background. So, you know, if you want to talk about being quantitative, you can begin talking about if 10% uncertainty is okay with you, then we can start talking about this MQC level as the beginning of being able to saying you have a quantifiable measurement capability. So that's my recollection. And what Bob said earlier was, well, you know, it's all tied up in the package of uncertainties, just depending on what level you want to be working at. It's just that the MARSSIM has decided it wanted to work at the MDC level, and but the MQC level is perfectly fine too, as some kind of rule of thumb to be able to begin saying you've got quantifiable measurement results. But other than that, it's you know, you depend on your uncertainty to tell you how good you are. How about that, Bob?
Okay, let me put my context. I understand what you're saying, and again, even 10% is kind of a paduma, as we used to call it in the nuclear industry. One of those wild ass guesses. Anyhow, when we're talking about detection with field instrumentation and following up with laboratory analysis, if we're going to use the field instrumentation, whether it be scanning or in place, to then determine where we're going to take confirmatory samples, we have to, in my opinion, we have to look at those areas where the scanning instrumentation is telling us we've got some detection. And if we look at using the MQC for any of that, I think we're going to be bypassing areas of potential concern. Now, will that mean that the number of samples that have to be taken may be increased? Well, that's certainly a possibility, but my background is one of public protection. You've got to protect the public. If you're going to return property to public use or expose people to potential contamination, you've got to be well assured that the measures that you've taken are protective. And so using something like an MQC, to me, is just, it's way too high. And I think we can all agree that the scanning instrumentation, while providing a preliminary assurance that cleanup has taken place and we've gotten the contamination removed, that has to be followed up by sampling. And following up sampling where you've looked at places where now you have detection, rather than waiting for you to get 10 times what the standard deviation of the background is, I think is unreasonable. But again, that's my opinion.
All right, thank you, Bob. I think Craig Yoder would like to weigh in.
Sure, thanks. I guess I just want to state that if you follow the MDC with all the uncertainties evaluated into it and kind of not get hung up on what's the background and standard deviations of that background. But if you look at how that curve of a measurement at the MDC, you have enough information to say you can quantify that. I mean, you've had to get to that point to establish the 95% confidence intervals around that mean. So this idea of MQC, to me, that's kind of like Bob, it's kind of an artifact, but I don't really understand how the value of it works. Because at the MDC, if you've done it correctly, you have a very quantifiable value with known uncertainty. So, or at least estimated known uncertainty. So that's just what I just want to add.
All right, thank you, Craig. Ken, I see you, but Catherine, your hand is still raised. Is
I'm
that from before?
figuring out how to lower it, unfortunately.
Okay. I just wanted to make sure that you didn't want to weigh in again. All right, Ken, back to you.
The uncertainty, the measurement uncertainty, just from counting at the MDC begins somewhere around 1 sigma, around 30%, just from counting. Okay, so, and then when you start throwing in all the other stuff, it could get quite a bit larger than that. So the question then becomes, is that good enough? And if it is, fine. If it's not, well, then we have to start thinking about becoming more quantitative. But I just wanted to bring up at the MDC, the uncertainty is about 30% just for the counting component.
Yeah, but Ken, I think if you read the answer or the statement I gave to the MARSSIM team the other day is that when you add the other components of uncertainty, the MDC is going to exceed by I would say a substantial value that just predicted by counting. It's going to be significantly higher. And so I think your uncertainties are going to be at that level are going to be better than 30%.
Absolutely. I totally agree with you. And that's why I said the 30% is like the lower limit of, you know, your uncertainty. It only goes up from there. Thank you.
All right, thank you. Before we move off this topic, Catherine, I want to come back to you and make sure that discussion provided the clarification you were seeking.
I think that we're going to have to do some discussing amongst this in the work group. I know that the MQC concept is included in both MARSSIM and MARLAP. And I think for laboratory measurements, we are looking for MARLAP to have precedence over any guidance given in MARSSIM. So we're going to be working with laboratory measurements that are coming back with an MQC on them. And MARSSIM was looking to do differently. We were looking to work with the MDC instead, and just making sure that the considerations around that we'd really considered all of what we needed to around that decision. So if the group that has addressed this question feels like they've got what guidance they can provide us on those considerations, I think we're satisfied.
Thank you. So anyone else on this particular topic first? All right, then, on anything else related to charge question 1.3. All right, it seems like we are ready to move on, and I want to offer all of you some encouragement. Recall that charge questions 1.2 and 3 were the most complex and challenging. So with those in our rear view mirror, I think we will make pretty steady progress here. So we have two more sub questions associated with charge question number 1. Let's try to get through those before we go to our break. Charge question 1.4, Earl Fordham.
Good morning, afternoon, all. We'll talk a little bit about the requirements for sampling and interpretation of the areas of higher activity. I would like to thank the team dealing with question 1.4, Dr. Benke, Collins, Duvall, Hamrick, Kirsting, Littman, Smith, and Szabo. Thank you again for all your efforts. Some of you were really burning the midnight oil last night. There was a lot of email traffic this morning from like 3 o'clock in the morning. I go, wow, okay. Appreciate your dedication. Charge question 1.4 has 3 parts to it, as we see on the first slide here. Is the discussion of survey requirements for areas of elevated activity technically accurate, appropriate, and clear? In particular, please comment on the decision to maintain the use of the unity rule for multiple areas of elevated activity, as shown in section 5.3.5, section 8.6, and appendix 0.4. And then the third part here, are there suggested alternatives to the use of the unity rule? Next slide, please. First off, I'd like to say is the unity rule was actually kind of an abbreviated derivation was shown in chapter 4, and that wasn't noted in those references earlier. But the charge question here is the current discussion in MARSSIM concerning the survey requirements for these areas of elevated activity has been viewed by our team as technically accurate and appropriate, but maybe not as clearly written as could be done. And we've seen several instances in the earlier charge questions where there is more detail, different language, additional detail, including examples. Examples in our particular case here, 7 and 8, could be clearer if the authors expanded the context and more sampling info was actually included. The idea here is to work the problem linearly, from discovery all the way through to surveying and any potential cleanup in between as a real life situation. My footnote here, I think, can be eliminated, where we may need to add a bullet on the scan MDC determination and uncertainty. I believe other earlier charge questions have addressed this, and we won't have to add anything in this one here. So next slide, please. The second part of the question was about maintaining the unity rule. And the team advised a change from our earlier stance to maintain the unity rule with some caveats. Most commenters endorsed the limits as stated in the draft rev, and the coordination with appropriate regulators, since the regulator is the one that will actually issue a license termination, giving site release. So it is good to, being a regulator and currently having a couple MARSSIM cleanups going on, I know it's critical for us to be involved early, often, and frequently. Some caveats there are listed. If multiple radionuclides are present in the elevated areas, the unity rule will be a conservative alternative and will be very helpful. Some of those limits that are shown can get involved when there's only one radionuclide. Particularly in our case, we're seeing some issues when we are cleaning up a building containing cesium-137. Also, the unity rule can serve as a great initial screening tool. Give you an idea if you got problems that you're going to be approaching unity, or if you're very conservative already. Next slide, please. The additional real-life examples would be useful. That seems to be a common theme. If the work group has got a lot of basis, I know the MARSSIM series of documents has been around for many, many years, so I would suspect that either the regulators or the contractors could be very helpful in this regard in providing some real-life examples that you might have to tweak them just a little to get your point across, but the idea would be is that they would be very beneficial, because I'm sure we're not reinventing the wheel every time somebody goes through a cleanup. And so learning from previous examples or mistakes would be very helpful to today's folks. The narrative and the equations before the examples are inconsistent, making examples hard to follow. Adding real life examples would be very beneficial here. An example that is illustrated in section 8.4 and the formulation of the unity rule suggests that DCGL-EMC is a level in addition to, not instead of, the DCGOW. So that we'll need a little clarification in that regard to make it useful. And the next slide, please. About specific alternatives, if we were going to toss the unity rule, did we have anything better to put in its place? We did not come up with any specific alternatives. Internet searches were not as fruitful as we had hoped. I'm sure the work group had tried this idea too. We do acknowledge that Section 8 did provide some alternatives there. Another one that team came up with, conservative alternative could use the dose at each elevated area, with doses from other areas being downweighted using the inverse square law, from the main site, and then the limiting case, whichever produced the number, highest dose would be picked as for compliance purposes. Use of any rule needs to be conservative and not increase the likelihood of any appropriate site releases. That's pretty obvious. Whereas the contractor or the licensee would be the one doing the work, it is the regulator that has to stand before the public and say, we can release this facility, and it is safe for the public to re-inhabit this area. Finally, we say there, don't believe the alternatives can exist to accurately reflect the potential, for a accurate dose assessment there. The last slide basically just says is that there are editorial comments provided by the team, and it will be available for inclusion in the written reports editorial section. Open for comments by the team, and turn it back over to you, Brant.
All right, thank you. So panel members, any comments or clarifications or questions on charge question 1.4? None?
Can I make a comment?
Certainly.
I think there's a distinction there that wasn't brought out, which is the application of the unity rule with respect to multiple radionuclides as opposed to the application with respect to multiple elevated areas. And the question was primarily directed at the application of the unity rule with respect to multiple elevated areas. So that's what the suggested possible alternative was aimed at. And I think that Dr. Baranki brought up the point that the inverse square rule may not be sufficient if there's a large contribution of dose from internal exposure, or at least it needs to be considered in that light. So just wanted to make those points.
All right, thank you. Anyone else input on charge question 1.4? Well, hearing none, let's move on to charge question 1.5. Craig Yoder, this will be the last one that we consider before our break. Craig?
Okay, thank you. I'd like to recognize the team for their tremendous help in getting all this information put together. That's Dr. Benke, Mr. Fordham, Dr. Golden, Ms. Hamrick, Dr. Kirsting, Dr. Littman, and Mr. Zavo. So thank you very much. The question is very specific, dealing with discrete radioactive particles. And just to read it, is the discussion and use of MARSSIM surveys for addressing sites containing discrete radioactive particles technically sound and appropriate? And is the description accurate? In particular, please comment on the rule of thumb for determining when use of MARSSIM may not be appropriate for survey units containing discrete radioactive particles. And basically they reference section 412.8 and appendix 05. So if we go to the next slide. So our first response to the charge question is that we felt that the discussion in the draft was incomplete. regarding radioactive particles. In particular, these offer very unique challenges and issues that have to be addressed, and they permeate through a number of the steps that go into a survey or site investigation. And so we believe that more material would be beneficial. And it should be perhaps not just confined to a small section in Chapter 4 or 05, because it does permeate a number of steps. So our recommendation is that the subject should be introduced no later than Chapter 3, maybe even in Chapter 2, because having a known history of discrete radioactive particles will influence future surveys and the establishment of DQOs and MQOs. The description of DRPs should be supplemented with statements regarding the difficulty of their detection, particularly as detection depends on the particular radionuclides that may be involved in the radiations that they emit. The likelihood that you'll have multiple DRPs is real, and therefore you shouldn't anticipate them being singular events. And the physical behavior of these discrete radioactive particles is such that they can be very mobile, not stay in one location. And as a result, they can provide a source of contamination for both instruments and people who might be working in the area. We'll go to the next slide, please. Our next response is dealing with that the dose pathways for discrete radioactive particles compared to bulk contamination at the site, they differ. As a result, the concept of the derived concentration guideline levels, the DCGLs, as used in MARCSIM, is unlikely to be effective for the DRPs. And that way you'll have to probably come up with some other avenues on addressing them. Our recommendation is because the general DRP guidance has not been sufficiently developed, decision aids and perhaps site-specific rules of thumb are needed to address when additional treatment of discrete radioactive particles is warranted. Such decision aids will allow resources to be directed to aspects most important in terms of dose and risk. That is, let's address the problem, alleviate the risk, and perhaps not have to spend so much time on statistical survey designs that a DRP may in fact direct one towards. Next slide. Our third response is that the caution of not using the MARSSIM survey strategies for the DCGL-M currently contained in the draft are appropriate. And so we agree with the hesitancy of the MARSSIM document to treat DRPs just as another elevated area. Next slide. Some further recommendations to the charge that we would like to make. The DRP should be addressed in those surveys conducted earliest in an attempt to find and remove such particles because of the potential health hazards posed to workers, and to avoid having to use rules of thumb to decide whether to use MARSSIM survey strategies or not. So we really think that the problem once becomes probable, that you deal with it as soon as possible. And there could be figures in the document that would help how to structure that process. The discussion of the DQO and MQO processes in Chapter 4 should address the influence DRPs will exert on both the method and measurement uncertainties that affect detection requirements, and that will in turn influence instrument selection and use. Again, we feel that as you step through the processes, there may be a figure, a flow chart, which I find be very useful for addressing the specifics of DRPs. DRPs are most likely to be discovered by scanning techniques, and so therefore the DQO and the MQO processes should be particularly attentive to that. And perhaps identify instrument response patterns or characteristics that might indicate the presence of a DRP. These can be hard to discover, and I think going into it, you need to have an understanding as to how your instruments are going to yield a signal that suggests a DRP. Next question, or next slide. More thought should be given to developing one or more rules of thumb because the current rule may not have the intended effect. The source detector distance and length of the elevated activity area required for the current rule of thumb may not be sufficiently determined, and therefore errors in either using or not using MARSSIM could happen. I should read Appendix O.5 should either be an example for addressing the DRP or an expansion of the basic concepts addressed in the body of the manual. And that concludes our recommendations.
All right, thank you, Craig. Panel members, any input for charge question 1.5? No? Anyone? All right, well, we have reached the point in our agenda where we are scheduled to take a break. We're about 15 minutes ahead of schedule. Why don't we come back at 2 o'clock Eastern? So that's 15 minutes from now. All right, thank you, everyone. All right, everyone. I have 2 o'clock Eastern by my clock. So we need to reconvene and get moving through the next set of questions. Those are charge questions 2 and 3 and their subparts. As I mentioned before the break, I think the really challenging questions are behind us. And so we should make have a little faster pace in this next set. But we begin with charge question 2.1, and Dr. Ken In, can you lead us through the summary, please?
Thank you very much. How do I see the slides? Here we go. To begin with, I'd like to express deep thank yous to the associate discussions for all of their thoughtful contributions. Dr. Benke, Duvall, Cronenberg, Littman, and Wall, particularly Dr. Duvall, who was actually supposed to have led this part of the meeting and had done all of the hard work of pulling all the information together for charge question 2.1. This charge question is, please comment on whether the description of updated measurement methods and instrumentation information from Chapter 6 and Appendix H are useful, appropriate, and clear. Next slide, please. The general comment is the description of measurement methods and instrumentation information in Chapter 6 and Appendix H are generally useful and in large part appropriate and clear. However, there are descriptions of concepts and operations that could be made clearer and more useful. With regards to the minimum detectable concentration, detection limits, and similar wording regarding detectability, the comment is discussion of minimum detectable concentration, the MDC, and detectability needs to be made clear and used consistently and concisely. The MDC and detectability are not the same and therefore are not interchangeable. Further, there are cases where the terminology is used without definition. For example, in Table 6.9, LLD is given units of activity concentration rather than counts. The recommendation is carefully review Chapter 6 and MARSSIM version 2 for the correct usage and thus consistent usage of LC, LD, detectability, LLD, MDA, MDC, and similarly related terms. Wow. We have an alphabet soup. With regards to completing the modernization of the measurement methods, the comment is, methods described in Chapter 6 have not all been uniformly modernized. For example, MDCR surveyor, that is the required MDC for the surveyor, appears from the context of the document that's value is arbitrarily based on what the project team deems acceptable, a survey efficiency. What is the applicability of MDCR surveyor for the GPS-enabled scan system? The recommendation, thoroughly review Chapter 6 and remove concepts and terminology that are no longer used or needed. Appendix H was scrubbed of obsolete and outdated instrumentation, and a similar scrubbing of instrumentation and methods is warranted for Chapter 6, where appropriate recent references need to be cited. Next, please. With regards to quantification of and description of uncertainties, comment is proper calculation and quantification of the various sources of uncertainty is of paramount importance when it comes to determination of the confidence interval. Recommendation is calculation and propagation of uncertainties should be consistent with other common guidance documents such as the NIST ISO Guide to the Expression of Uncertainty in Measurements, the GUM. Next, please. With regards to the Appendix H, the comment is the updated and expanded Appendix H assure that it will remain the top download for years to come. However, there is room for further improvement. The recommendation is references to technical information contained in Appendix H needs to be properly cited. An example of where a citation of the literature is required is page H10, lines 23 to 25. Specific scientific information needs to be properly cited here. It is stated in MARSSIM version 2 that those interested in purchasing or using the equipment are encouraged to contact vendors. So adding references to the scientific literature is a way of giving specific information to the reader without becoming an advertising platform or the appearance of an endorsement of a particular manufacturer. Next, please. And finally, editorial comments. Numerous editorial and specific comments are tabulated in the detailed draft comments. Additional editorial comments can be made available. And I think that brings us to the end of the presentation.
All right, thank you, Ken. So panel members, any input on charge question 2.1? No? All right then. Let's move on to charge question 2.2. And Dr. Richard Smith, please take us through the summary.
Okay, thank you very much. Just a point of clarification here, since I did present some slides yesterday, some of them I've just kept in this slide presentation because I feel that they're important for our final report. They're sort of a bit of background of what this is all about. And I think, you know, certainly when the SAB sees this, they will want that sort of background. But I'm not going to repeat what I said yesterday. So let's just quickly read the question, comment on whether the additional optional methodology for the use of ranked set sampling and specific reference to Appendix E for hard to detect radionuclides, comment on whether this is useful, appropriate, and clear. So next slide, please. Next slide, because this I did yesterday. Next slide again. Next slide again. So I've condensed and consolidated the comments from panel members, and the remaining slides will reflect the further discussion that took place in the meeting yesterday. And also I want to acknowledge some comments from Dr. Een that he sent me last night. And by the way, in fulfillment of Dr. Wong's request, we haven't attributed any of these comments to any specific panel members. So he'll go with the actual comments. The description of the method is sound, but the style of writing is more suited to a statistician than the general user. It would be good to add more motivation, and sorry, that should be and explanation for the method. Next point, one panel member felt the method would not provide reasonable directional assurance that hard to detect activity concentration areas will be properly selected. Significant information and guidance on how to perform this assessment is missing. And by the way, just as an interjection here, I don't feel that this should be recorded as a dissent. I just put in one panel member because that comment actually did come from one panel member. I don't think the rest of us were disagreeing with him. I think this, that just reflects the way the discussion went. Next bullet point, there should be better discussion of practical issues such as when you should use this method at all, what alternatives might be available, and we mentioned things like stratified sampling. How, and people asked, well, how should these rough measurements that we're using to select the subsets, how should they be determined, and what sorts of correlations are needed to make the method useful? And the last point was about more detailed works examples. Next slide, please. So other comments that were raised, we had discussion about whether these assumptions are really satisfied for nuclear survey applications at all. The fact that the nuclear survey context, we're typically talking about counts, not normal distributions. And I think it was actually the same panel member, but I know somebody on the panel raised the question of whether the suitable type of proxy variable even exists. We thought that the discussion should be expanded beyond just estimators and standard deviations. We should get into decision-based outcomes. So this is not so much going on when you use the method, but how you interpret it when you do use it. And then, there is the general point here that if indeed the RSS method improves on simple random sampling for calculating confidence intervals, it should improve it for other kinds of statistical decision things as well. But that isn't brought out in the discussion of this appendix. There was also some comment about using calibration methods to use the rough measurements differently. I don't know whether we want to fold this into the comment about regression and ratio estimators, but I think it's a similar sort of point. There are other ways you could use these rough measurements besides doing this particular type of sampling. One person, I think this might have been Dr. In, had explicit suggestion we should include some cautionary text about when not to use this method. And again, this is not meant to be a disagreement. I'm just quoting what one particular person actually said. Much of the major decision concepts are statistical and the text is thick with statistician vernacular. It would be merciful if the statistician ease could be dialed down and in more lay language. Okay, well, that wasn't me that said that, but I think it's a perfectly valid point, and I did have that concern myself. So I think we should reflect that in our report. So next slide, please. So conclusions. So trying to sort of pull these together just as a few bullet points. More careful explanations of the method to make this useful for somebody without a statistics background. Better discussion of the usefulness of the method in the nuclear testing context, including, I suppose, circumstances when it would not be useful. Have a more thorough discussion of examples, when to use the method at all, how to use the results for other kinds of decision making. Maybe have some comparisons with alternative methods. And by the way, I haven't listed all the technical queries here, but I had quite a few, and Dr. Littman also had about a page worth of technical queries. I didn't put these on the slides, but I assume they will be taken into account in the final report. So that's what I have to say. Open it up for discussion.
Thank you, Richard. So panel members, any input on charge question 2.2? Well, you all must be tired. Maybe you should have gotten some coffee on the break. All right. Well then, hearing none, let's move ahead.
Could I, this is Alton Sabo. Could I just make one comment? I couldn't unmute myself for 2.1 when you were wrapping that up.
Oh, sure. Go ahead.
And I'm sorry, Dr. In, I didn't realize you were doing the presentation today. I know an example that was given of perhaps needing more citations was radon equipment, for example. And so that was something that I did get together and sent Tim a whole page, and somehow I confused my list and didn't include you on the CC, but I did CC Dr. Wong with that as well. So hopefully those can be taken into the note. Tim reminded me of what the citation was for radon, and he was right. It was like 34 years old and badly out of date. So we added about, well, a fair number of citations on that particular topic. Sorry about that.
All right, thank you. So circling back to charge question 2.2, any additional input on that before we move on? All right then, charge question 2.3, Eric Golden, please take us through the summary.
Well, hello everyone. I'd like to preface my remarks pointing out that Dr. Robert Littman did the majority of the work on this section. And we also had some input from Dr. Kenneth in as well. So it looks like a lot of slides, but we'll go through this fairly quickly because it's pretty straightforward. Our charge was to look at the Chapter 5 examples and comment on the usefulness and the accuracy of the new and additional examples provided in Chapter 5. The next slide shows a kind of a summary that overall the examples are useful and provide a means for users to see how the manual guidance can be implemented. Each example, it's always good to provide additional detail on the calculations and the use of tables that are cited in the text. It's not always a good assumption that the user is well versed in sampling theory or statistics. And so the more references back to other places and description is better. The next slide shows that the first three examples, 1, 2, and 3 in Chapter 5 are identical to Revision 1 of MARSSIM. The first one is a scoping survey checklist. And just one quick question is whether the checklist should refer to the flow chart that's early in the chapter. And that's a comment that we have on a couple of the checklists. Number 2, the characterization survey checklist is identical to Revision 1 as well. This one has some limited guidance on scoping for contamination in matrices other than soil, such as groundwater, surface water, sediments, and the like. And the information is important to assess how the site contamination is impacted. MARSSIM doesn't provide a lot of guidance on how to use this additional information. And again, it's a question of whether the checklist, the characterization survey checklist should refer back to the flow chart earlier in the chapter. The third example is a remedial action support survey checklist, and it's again identical to Revision 1 and the same comment, should it refer back to the flow chart. The next slide deals with some modified and well, the first one, example 4, is a modified example from Revision 1 that is scenario A, use of the Wilcoxon rank sum test. And it changed considerably. It was a soil example. Now it's a building surface, and it is improved from the Revision 1 version. Example number 5 is the Wilcoxon rank sum test under scenario B. So that's a new example. Same kind of situation of a building surface, and it is good that scenario B is added to Rev 2. Dr. In also pointed out the cautionary note of when not to use the Wilcoxon rank sum test would be a good idea. And partly because that's not addressed until several chapters later. And so somebody working through the document might not know that in advance. Next slide shows, talks about example 6, dealing with the sign test. And this again is a new example. Provide for scenario A on determining the number of samples to be selected. There's some detail here that Dr. Littman provided It shows how the calculation is done, but it would be helpful to show that as the errors increase from perhaps a 5% error to 10%, that the measurement uncertainty has to get much smaller, or you'll get yourself in trouble. And this type of discussion ties to the decision being made using the data back to the original MQOs and DQOs. And then Dr. In's cautionary note, again, when not to use the sign test. The next slide is examples 7 and 8, which are both modified from revision 1, and they are determination of whether additional data points are required. The first one is, let's see, it's it shows how the determination is made, but it's not clear where all the values came from. I think Dr. Lippman found out eventually where the value 27 in the example came from, but it should be referenced back so that it's a little easier to understand where the table is that the number was derived from. Example number 8 is a good contrast to the one in example 7. And there is a typo there where there's a miscalculation of the area in the triangular sampling pattern. Next slide is for examples 9 and 10. The first one, well, they're both identical to revision 1, the random sampling pattern and the triangular sampling pattern. There's a typo where in example 9, it references the wrong table. And it could use, the new revision could use some more clarity on how the table is used to select the locations where you start, the random location to start. That method should be explained in more detail. Similarly, example number 10, the triangular grid, it doesn't really clarify in detail how you get to the random starting point in enough detail. Next slide is example 11, the last one in the chapter, and it's a sample checklist for the final status survey. It does provide additional detail over the revision 1 version of that checklist, and the two documents diverge significantly because the flowcharts in revision 1 and revision 2 are substantially different. So Rev 2 goes into significant detail and is a more comprehensive. I think the next slide is some conclusions, just so that everybody understands. Of the 11 examples in chapter 5, 5 of them are identical to revision 1. 4 of them were changed with additional information, which is good, and 2 of them are brand new. The new ones are an improvement and are needed. The unchanged examples were mostly reformatted, so they do stand out better and are easier to read. They could use additional information, as we pointed out, and the few typos obviously need correction. And in summary, to answer the original question, is that the examples are a marked improvement over revision 1. I think that's it for us.
All right, thank you, Eric. Panel members, input on charge question 2.3. All right.
General question, was there any consideration of additional examples needed?
I don't think our group came up with any suggestions for this chapter. There are places elsewhere in the document. I think other groups suggested more examples, but not for chapter 5. Not that I'm aware of.
I see.
All right. Any other comments? All right. Well, then let's press ahead. Charge question 3.1. Harry Cullings, can you please give us the summary?
Okay, I should begin by thanking Doctors Amundsen, Dower, Cronenberg, Quinn, Smith, Stram, and Wang. And the first, the question is relatively short. It says, please comment on the revised description of how to set the lower bound of the gray region, LBGR, and its likely effectiveness in encouraging users to rely on site-specific information for doing so in Chapter 4 and Section 5.3. So the first point has to do with use of a rule of thumb, such as using half of the derived concentration guideline level for setting the lower boundary of the gray region. And it's that the value of site-specific information about the residual level of radioactivity is likely to vary from site to site. And the suggestion that the LBGR be set to a value near to the median seen in preliminary data is a good one, so long as the preliminary data is reasonably informative. In cases where preliminary data are limited, adherence to some kind of heuristic rule, such as half of the DCGLW, probably can't be avoided. Of course, the sample size needed can be reevaluated as the data comes in, and the median of a first set of observations, and if the median of a first set of observations is far below the DCGLW, the necessary sample size can then be lowered. A development of a good case study as an example would probably be more persuasive than the very short description of using various possible preliminary data sources without giving any specifics. Unless the preliminary data is strong, it's natural to fall back on however inadequate hard and fast rule. So it wouldn't be a bad thing for the manual to point that out, that there are cases where it really is necessary to use a sort of rule of thumb like this. And regarding that, there's another suggested rule of thumb, which is that the LBGR could be based on a gray region that is something like 1.67 times the sigma of the measurements for cases where the available data are very sparse. Also in Chapter 4, it needs to be indicated clearly that in scenario A, the LBGR, the lower boundary of the gray region, is in fact the decision level. It's the level below which the measurement is statistically considered to be below the DCGLW. And that's sort of lost in the discussion in Chapter 4, and it was really confusing to me when I first read that chapter. And then can we move on to the next slide? Also for scenario B, we should add some material describing the use of a series of power curves as a function of the decision level for different sample sizes to evaluate whether the decision level for a reasonable study size is unrealistically large in relation to typical requirements. And that's the scenario B, where we're assuming that the null hypothesis is that there's no contamination. Also, we should consider moving the material in section 4.12.3.1 to Chapter 5, where it's also covered with a higher level summary of sample size determination to be being presented in Chapter 4 and reference, as is already given, to the appropriate sections in Chapter 5. Also, we could add two figures like figure 6.1 from Chapter 6 to Chapter 4 to illustrate the relationships in scenarios A and B, which are nicely complementary relationships, and describe in simple language how the relative shift, the width of the gray area, depends on the values of the measurement error sigma and the alpha and beta error rates. And then in section 5.3.3.1, we could include a short paragraph on considerations for setting the lower boundary of the gray region prior to the examples, discussing how the site-specific information, along with some emphasis on conservatism, is applied and why this was chosen as a basis for setting the LBGR. And I was particularly curious about the fact that there's no discussion of how that guideline for using the conservative estimate of the amount remaining in the survey area as the lower boundary of the gray region. So I think it would be really good to explain that. And I think that's it for that question.
All right, thank you, Harry. Panel members, any input on charge question 3.1? Well, I think I'm detecting a theme. You all must be running out of steam on this. All right, well then, let's move ahead. Charge question 3.2. Larry Dower, can you take us through the summary, please?
Yep. Hello. Thank you very much. Thanks to Drs. Amundsen, Benke, Fordham, Hamrick, Quinn, Sabo, and Dr. Wall. Charge question 3.2 is fairly simple. We'll cover it in a few slides quickly. Please comment on whether avoiding the use of the term, quote, area factor improves understandability of the elevated measurement comparison concept, specifically referring to sections 8.6.1. Just to start with, most of the associate panel members who reviewed this also looked through the rest of the document in addition to 8.6.1. So some of these comments are more broadly given. Bottom line, overall, there seemed to be agreement that avoiding the use of the Rev1 area factor designation and utilizing the ratio of the EMC to the wide area release criteria does, in fact, emphasize the need for site-specific modeling calculations. So the answer is yes, it does improve understandability, and we think gets at the underlying reason for making that change. While the understanding of section 8.6 is improved without the use of the term area factor, it was suggested a figure could perhaps be added to enhance the overall understanding. And then we pointed out that there were several sections of the current Rev 2 draft that continue to utilize area factor and thereby introduce some levels of confusion. We list those in those areas, perhaps remove the historical approach discussions if appropriate, or simply refer to the ratio itself rather than area factor, or just delete any reference to area factor. Next slide, please. Section 8.6, example 14, specifically refers to area factor, and it introduces a good bit of confusion because it's central to the example. So again, perhaps refer to the ratio, which would also encourage the importance of site-specific modeling, especially since it was central to that example. The inclusion of specific items associated with area factor, of course, are included in many areas of Appendix O. So the broad comment is to relook at Appendix O. We gave several alternative, perhaps a bit editorial suggestions, but the major comment is to try to remove the confusion, either remove area factor altogether from Appendix O. Certainly no need to include the reason why you're not using area factor in Rev 2, even though you did in Rev 1. And maybe some of those examples should just frankly be eliminated. Alternatively, though, if it was important to maintain historical discussions, then remove them from elsewhere, make it clear, and then cite perhaps some examples of state regulator documents for clarity. But still clearly note that Rev 2 encourages utilizing the ratio. And again, the glossary has the definition, but perhaps shouldn't be included or should be made clear or referred to a historical definition. I think that about covers those comments.
Okay, thank you, Larry. Panel members, input to charge question 3.2. All right, then. Moving on to charge question 3.3. Barbara Hamrick, can you please present the summary?
Yes. So first, I'd like to thank Dr. Wong, Dr. Yoder, Dr. Dower, Dr. Benke, and Dr. Quinn for their assistance on this question. Essentially, the charge question, I believe, is there. Please comment on the effectiveness of the new organization of Chapter 4, considerations for planning surveys to improve the understandability of the chapter. And to be honest with you, after the summary was presented with the preliminary remarks, nothing was really changed. There were no further comments. There were no objections to what was presented the other day. So I don't know if it's worthwhile reading through these again because it's essentially unchanged from the preliminary discussion. I'll leave that to you, Brant.
I think I agree with you, Barbara. If nothing has changed, then we probably don't need to walk through it in detail.
I mean, the bottom line conclusion was we all thought this was a significant improvement over Chapter 4 in version 1, and so they have significantly improved this. But there are additional changes and reorganization that we've listed out, and which of course will be in the report, that we think would further enhance the understandability.
All right, thank you. Panel members, and any final input on charge question 3.3? Okay, well, we are rounding third and coming home. Dennis Quinn, can you please give us the summary of charge question 3.4?
Okay, certainly. Okay, charge question 3.4. Please comment on the effectiveness of moving derivations from Chapter 5, Survey Planning and Design, to Appendix O to improve the understandability of the chapter. And this will be rather brief because there was general agreement that the change to Chapter 5 by moving the derivations to Appendix O is expected to improve the understandability. Some specific items noted as improvements are that the flow charts for scoping survey, characterization and remedial action surveys, final status survey, and integrated survey plan for the FSS were noted as good. Some formatting improvements, some improved cross-referencing to other chapters and appendices. And there's an improved section 5.3.1 concerning scenario selection and LBGR determination. Next slide, please. And there was a few suggested improvements and details. There's not much more details in this, but we'll provide the details for the final report. There's several locations where it was recommended that the reference to Appendix O should be added. So there's specific call-outs that reminded people, certainly in section 5.1, the introduction and discussions of the various tests, where you could refer right over to Appendix O. And it was also an editorial suggestion to add to the description of Table 5.2 to state that the values were increased by 20% to account for missing or unusable data and uncertainty in the calculation and the value of N. So rather brief, but that's all I have on 3.4. And I do want to thank Drs. Amundsen, Dower, Fordham, Golden, and Yoder.
All right, thank you, Dennis. Panel members, input to 3.4. Okay, well, before we move on to next steps, I would like to provide one final opportunity for input into any of the charge questions that we've talked about today. Anything you thought of that you missed the first time around? Craig, please go ahead.
Yeah, this is just more for Kathleen, and from her listening to what we're saying, does she feel like she understands what it is we're trying to communicate for the MARSSIM committee?
Yes, I want to thank you and the rest of the members of the SAB RAC. I think that your deliberations this week have been, what's the language we've been using? Clear, adequate, all of the descriptors that you've been trying to apply to us. I think that it's been really an excellent opportunity to listen to you go through your deliberations here this week and to hear the wide range of opinions that we've had. And I know that they'll be reflected well in the report. And I think that we have a good understanding of what you're looking for, and we'll be able to consider it as once the MARSSIM work group gets back together at the end. So thank you for checking on us. We really appreciate it.
All right, panel members, anything else? All right, I will turn it. Oh, Ken, I see your hand raised.
I was wondering, well, this is really outside of the scope of what we've been talking about so far. And I was wondering if the writing committee had considered how performance testing programs could help in the verification parts of what they're concerned about. For example, doing a performance test for scan-only instruments to set up a program for that, so that you know that you have verified the capabilities of the instruments and that they work on an ongoing basis. And perhaps if this is a good idea, then you could put some guidance in the MARSSIM for such a thought. And you could also go bigger and think of, since you have a multi-agency group sitting at a table, you can ask if all the other federal agencies would like to participate in such a program and share costs.
All right, thank you, Ken. Tom Brennan, I see your hand up.
Well, before I jump in, because mine was a little different, does anyone have a reaction to Dr. N and close out that comment first?
I think that may have been a question for those of us on the MARSSIM work group and the federal agencies that we represent. What I'm going to say, Dr. N, is I feel like that may be outside of our scope at this time, but certainly you're talking to people within the federal agencies that may be interested in such recommendations. So certainly feel free to make that recommendation. I'm sure that the folks in the various federal agencies are happy to consider it.
Yes, there was a time back, the Department of Energy was doing some cleanup work and among their sites, and there was a consolidated program of not only the testing but audits as well, so that there's consistency among the different groups. Because the laboratories that were doing the measurements were really bogged down by being audited numerous times by the different agencies, because they were all setting up their own criteria. So if there was a common basis for criteria, then you could all use the common tools for assessing the ongoing QC and quality assurance and have homogeneity across the federal agencies. It's just a suggestion to save money.
Thank you.
Thank you, Ken. Tom, if I could put you on hold for just a moment. Eric Golden, I saw your hand was up and now it's not. Was there anything you wanted to add?
Well, I was just, from a practical perspective, in the power business, nobody would be involved in this kind of work unless you were fully qualified, and that would include some kind of training. So, and maybe at a much smaller facility, most of this kind of stuff would be way over the heads of the people assigned to do some kind of a license termination. So I don't think that MARSSIM really needs to be a complete cookbook. And you know, I just thought I'd point out that it doesn't have to do everything. So I personally used MARSSIM Rev 1 way back early after it was issued. And it was a giant leap for me because I don't have a good background in statistics, but we were able to, with some training from the Oak Ridge folks, get by and do some adequate surveys. Just thought I'd point that out.
All right, thank you, Eric. Anyone else before we turn it over to Tom? All right, seeing none. Tom, please go ahead.
Well, before Diana and Brant take you through the last step and describe what's next and what's ahead, I just want to take this moment and reflect on how great the summaries were. I mean, listening to today's meeting, hearing how organized your thoughts were, it made me feel great to think about the time you took to prepare for this meeting, to come to this meeting, the next writing sessions that you'll be doing. I just, how much I appreciate the public service that you've given to the agency and the other federal partners involved with this, to take this much out of your professional lives to help us here today. So I just wanted to just say thank you. And Diana, thank you for doing such a great job as a DFO, and thanks to the chair. And I'm just going to turn it back over to them, but I just wanted to take this opportunity to express my gratitude.
Thank you, Tom. Really appreciate the encouragement. And I would also like to echo what Tom said. As the chair, it's been a real joy to work with all of you. I appreciate your professionalism and your dedication and how much time you've dedicated to this. So, Dr. Wong, we are to the point where I think you're going to tell us about the next steps.
Thank you, Brian. The review meeting went very well, and I think everyone will agree on that. As I mentioned yesterday, the final product for this review will be a panel report submitted to the Charter SAB for quality review, and then the report has to be approved by the Charter SAB before it can be submitted to the administrator. So from where we are today to the final product, what must the panel do next? And that is what I'm going to talk about now. So that will be the next steps the panel will have to take. Now, today the panel just finished deliberation of the summary slides. And I can see that the panel really put in a lot of work in preparing all these summary slides, and I have to agree with Tom totally, because last night, even very late at night, I can still see a lot of email traffic. And so it's early this morning. So I can see the dedication from the panel members. I really appreciate the dedication and the effort from the panel. So from the deliberation, I can see that some of the slides will need revision. So that will be the first step the panel has to do. So when there are some revision that needs to be made, the lead discussant will make the revision and circulate to the panel members and send the revised slides back to me by next Tuesday. That is January 19. I will then compile all the revised slides and post on SAB website. I will also circulate the revised slides to the entire panel, because the revised slides will be the basis for the panel to develop the written response to the charge questions. Now, the panel members may decide to revise the individual response to charge questions. If they want to revise the individual response, they can send back to me by February 1st. It's not a requirement, because we already have very detailed discussion in the summary slides. However, if some of the individual members want to revise the preliminary comments, and maybe they want to put something in more detail, or maybe they want to do some research on certain topics, they can do so and send back to me by February 1st. Again, I will compile the revised individual comments and post it on the website. Now, getting back to writing the written response to the charge question. The lead discussants will be our lead authors for the charge questions. So you have 5 weeks from today, which will be February 18, to complete the written response to the charge question. The lead discussant will start drafting the written response and then circulate to the team members for comments. And the team must reach consensus before the lead discussants send back the written response to comment to me. Again, the deadline will be February 18, which is 5 weeks from today. After I receive all the written response to the charge question, I will then assemble the first draft of the report. The report basically is a compilation of all the different written response to all the different charge questions. And of course, there will be a lot of editing and formatting and so on. And I will be sending out a sample SAB report to the panel so they will know how SAB report looks like. So that will probably make it easier in the report writing process. So after we do all this editing, formatting, and so on, and then the report will be reviewed by our panel chair. Then when we think the report is ready, we will post it on the SAB website for public comments. And also, the entire panel will have an opportunity to review the entire report, because when the different teams work on the different response to charge question, they only work on the specific charge question. They do not have the chance to look at the entire report. But once it is finished and posted on the SAB website, and then I will circulate the report to the entire panel so that the panel members will have opportunity to review the report. And then we will also schedule a follow-up teleconference for the panel to deliberate on the draft report. Of course, I will have to ask the panel members' availability for me to schedule this follow-up teleconference. My expectation is that the teleconference will probably be sometime in May or so, no later than early June, February and May, so that we can finish the report early. I don't think I have mentioned that we have a deadline for completion of this project. That is, we finished the panel report and then we submit to SAB, Charter SAB for quality review, and then the report has to be approved by Charter SAB, and it can be have to be submitted to the administrator, and the deadline for the completion is by the end of September. That is the end of the fiscal year. So basically now we have a deadline to work with, and basically we just work backward. So before we can, so going back to the follow-up teleconference, the idea of the follow-up teleconference is for the panel to deliberate on the panel report and also to reach concurrence. Of course, the report will have to be revised, and then the panel members have to reach concurrence before we can post the revised report on the SAB website again. And this revised report will then be submitted to the Charter SAB for quality review. My expectation is that the quality review probably sometime in July, probably the end of July, because we have to allow enough time for the Charter SAB to have a public meeting and review and comment on the report. Now, as I say, the Charter SAB review meeting is also a public meeting, so that the panel members can listen into the review meeting. And the Charter SAB members then will vote on their decision. Usually there are 3 options. The best option you can get is that there will be minimum revision, and the report will only have to be worked on by the panel chair and also the Charter SAB chair. And then it doesn't have to be go back to the panel or even the charter SAB members. Just the two chairs work together. So that will be the best option. A more common option will be option 2. There will be more extensive revision needed, and then I may invite some of the panel members on the MARSSIM panel to address some of the comments from the charter SAB, and then the revised report will have to be reviewed by a select group of charter SAB members before it is approved by the chair of the charter SAB. So that'll be option 2. And the last option will be option 3, which is the report is rejected and sent back to the panel for rework. And I don't think we want that. But it does happen sometimes. So of course, knowing that the panel, we have a lot of experts on the panel, and the panel is so dedicated. So I'm very confident that we will probably achieve the best option. I'm very, very optimistic. So that is the process. So is there any question about the process that we have to go through?
Diana, I have one question. When the charge questions leads start distributing the report to the team members for review, do you and Brant want to be included on that as well?
Oh, yes, I have to, because as a DFO, I have to be involved in all your email exchange. And sometimes we may have to schedule a teleconference just between the team members, because there may be some differences and something had to be hashed out some more. Yes, I will be involved, and the chair can be involved also.
Thank you.
Any more questions?
You said individual revised comments would be due February 1st. Are those sent only to you, or are those sent to the charge question leaders?
No, it's individual. It's from you to me, and I will compile it. It's individual comments.
And then you're going to send them back, or?
No, I'm not going to send them back. I will assemble them.
Right. Okay. Got it.
It's just like the first time.
Yes. Okay. Got it. Thank you.
But how do those comments get incorporated into the draft report then?
Okay, good question. The lead discussion will reveal the revised comments, and then it will be incorporated into the written response to the charge question. But of course, we don't expect everybody to revise their comments. So,
will you be sending out these notes again?
No, as I said, I will compile and post it on the SAB website.
No. The steps that you just outlined about the final steps, this whole process, would you be sending that?
Yes, I will send out email. I will send out email to the panel members to remind everyone about our deadline.
Thank you. Thank you.
Thank you.
This is Eric. What's the difference between the optional revised response on February 1st and the written response on February 18th?
Oh, the February 1st is individual revised comments. It's just like the first time when you write up your preliminary response to charge questions that I compile. So for those of you who wish to revise the individual comments, here is your opportunity to do so. Send back to me by February 1st.
Okay, thank you.
Diana?
Yes.
I see that Amy Cronenberg has her hand raised.
Okay, Amy, go ahead.
Yes, I have two comments. The first is I am wondering who will be checking for consistency in.
You mean the different response to different charge questions?
Yes, because in several places, the same quantity came up as a discussion point.
I will, because I'm the one who will be looking at all the different
to make sure that the comments in the end are harmonized.
Yes,
That's
that is my job. I will read through all the responses to charge questions.
okay. So that's number one. And my second point really is to thank all of the people from EPA and the other agencies who participated in drafting this report, and for all the work that you all have done under somewhat challenging circumstances. And I don't just mean the pandemic. The country owes you all a debt of gratitude for trying to keep us all safe. So thank you.
Thank you for your comment. Is there any more questions?
About the revised slides, is I'm one that has to revise one of my slides. When do you need that by?
Next Tuesday. Because I don't expect a lot of work in the revision, because you already know what should be changed.
Yes, that's right. It's certainly not a lot of work. But you need it by Tuesday. Thank you.
Any more questions? If not, I would like to thank the dedication and hard work of the MARSSIM peer reviewers and also the public listening online. Also, I would like to express my special thanks to Catherine Sneak and also the MARSSIM workgroup members for their presentations and being online in an efficient and responsive way, for providing your interactions with the RAC MARSSIM peer reviewers. Finally, I say that over and over again, but the MARSSIM peer reviewers and the chair deserve our special thanks for their work and robust deliberations and contributions that will lead to the recommendations and advice to the agency and how the draft MARSSIM Revision 2 document will be refined. And this concludes the SAB Augmented RAC meeting for the peer review of MARSSIM. Today's session is now adjourned. Thank you.
Thank you, everybody.
All right, thank you, everyone.
Thank you.
Bye.
Thank you, Brad.
Thank
Thank
you.
you.
Thank you all.
Bye, everybody.
Take care, everybody.
Bye-bye.
Thank you.
Thank you.
Thank you. Diana, is there? Oh, Diana is gone. All right.
She's
Thank you.
gone.
We'll talk to her later.
See you later.